We see the universe at 400,000 years after the Big Bang as the cosmic microwave background. Every direction that we look, we are surrounded by a sphere of microwave radiation that's traveled 13.7 billion light years to reach us. We see it as 3 degrees Kelvin in every direction. A cubic centimeter is about the size of a sugar cube. At 400,000 years old, there were about 250 protons and electrons per cubic centimeter. At 400,000 years old, the universe had 1 billion photons for every proton. The cosmic microwave background is the same as the photosphere of a star. It's the point where the electrons attach to the atoms, allowing light to escape. The cosmic microwave background radiation that reaches us is stretched by the cosmic expansion down to the microwave frequency. Almost all photons in the universe were made in the Big Bang, but they are invisible to us because they are in the microwave part of the spectrum. We see them as the microwave background. Their low energy makes up only 0.005% of the universe. About 10% of the static on old non-cable TV is from the cosmic microwave background. There are parts of our universe that we cannot see beyond the microwave background. The Big Bang made about as many neutrinos as photons. Just like the microwave background, there is a neutrino background. The cosmic microwave background radiation that we see as 13.7 billion light years away is currently about 50 billion light years away. And it has spawned galaxies that we have not seen. Out of all of the atomic matter in the universe, the protons, neutrons, and electrons, 99.9% of it is too hot for atoms to survive. Only about 1/10% of all the atomic matter in the universe is cool enough for atoms to survive. There is still some primordial material in the universe that has never been processed by going through a star or a supernova. Everywhere in the universe is about 75% hydrogen and about 25% helium. Even in the oldest stars, almost all of the hydrogen and helium in the universe is 13.7 billion years old. Everything else is much younger. Less than 4% of the atomic matter in the universe is made of elements other than hydrogen and helium. Very old stars have much less of the heavier elements, but they still have about 25% helium. A 7-to-1 proton to neutron ratio makes 12 hydrogen nuclei and 4 helium nuclei, which equals 75% hydrogen and 25% helium. Elements above hydrogen and helium have more unstable electrons, which allow photons to form and carry away energy more easily. Protons and neutrons orbit in shells in the nucleus. Neutrons require much less energy to join a nucleus than another proton. Neutrons are added to the nucleus in the center of stars until one turns into a proton and an electron. As the sun accreted, when the temperature reached about 10 billion degrees, hydrogen began to fuse into helium. Elements heavier than helium form when stars run out of hydrogen and turn into red giants. And helium fuses into all of the heavier elements all the way up to iron.